When you first start Studio Tools version 13, your layout will likely look as follows. Notice the large window. This is what I will refer to as Studio. This is where in a moment I will bring out the modeling windows. On the left-hand side, there's a window called the palette. This has all modeling tools in it. On the right-hand side is the control panel. The control panel will have tools in it that will allow you to quickly evaluate surfaces. And on the bottom, there's a window called Shelves. The Shelves is a quick and easy way to put some of your favorite tools in there for access. However, for this particular demonstration, I will actually close the Shelves window by clicking on the X box in the upper right-hand corner. I want to bring the palette onto the top to maximize the workspace. To bring the palette on top, on Studio, click on Preferences, use the right mouse button for this, and then onto Interface, Palette Shelves Layout, Options. Whenever I say the word Options, I'm referring to the option box that is next to the tool. This will bring up a window that has 4 executive buttons. The Reset button will change all things that you've done back to its default. The Save button will, if I make a change, save that change but not execute it. The Exit button just closes the window without doing anything. And the Go button will execute whatever change I made. So on the palette position, click on Top, click on Go, and this will maximize your workspace. Next, start a new file. On Studio, click on File, New. This will give you a new file with 3 orthographic views and a perspective view. Again, depending on the software package that you're working on, it might be that some of the windows have slightly different names, but essentially they will all do the same thing. Let's start to examine the window a little bit. The top window, it gives you the measurements in millimeters. This icon here just says that each grid is 100 millimeters in size. We will change that in a moment so that regardless of which package you're working on, you will get consistent results with what I'm showing you. The windows have a small magnifying glass here. This can be very useful if you want to quickly zoom into your geometry and just work up on a detail. You can also modify the position of this just by clicking and dragging on it. Close the top magnifying window again. The next one over, the circular icon, is one that allows you to zoom in and out of your view. I'm doing this with the left mouse button. The one over with the 4 arrows will allow you to track in your view. And I'm keeping the left mouse button pressed and move the mouse very slightly. Now notice that the perspective view also has an additional icon, which is this one here, which allows you to tumble or rotate around your geometry. Notice that we have the center of the perspective grid in here, XYZ axis. Also, if you want to make any of these views large, what you would do is click on this icon on the upper right hand corner of that view. This allows you to quickly maximize the view. So you can look at the perspective view, start tumbling around here. Now this is a little bit difficult to get used to at first, especially if you're trying to zoom in and out of your geometry. It's very easy to get lost at first. So what I want to show you is the first shortcut that you will use on your keyboard. Hold down Alt and Shift together while you're in the perspective view, and you will notice a viewing panel coming up here. So this allows you, using the left mouse button, to very controlled rotate around the scene. Now the middle mouse button will allow you to track, and the right one will allow you to dolly or zoom in and out. This will work equally well on the other views. The middle mouse button, on the top view now, will allow you to track, right one dolly. The left mouse button will not work. You cannot tumble in the top view, for instance. I'm going to start and introduce you to the Rail tool. Go ahead and start a new file. This new file, make sure that your grid spacing is set to centimeters and the dimension set to 1 unit each. Again, this is done under Preferences, Construction Options. Under Units, Linear, switch the main units to centimeters, subunits, positional units, and click on the Reset Grid button. This will help to have your results be closer to the ones that I'm showing you. Also, make sure that under Construction Options, under Grid Presets, switch the grid spacing to 1 and the perspective grid to 40. Okay, so now that this is set up, let's start to begin using the rail tool. I'm going to switch to the side view, zoom in here, and start with a new curve that essentially, if this was a product, would be the center line of the product. Try to use as few CVs as possible. For the next curve, I need to build it perpendicular of the first one. So I'm going to hold down Control and snap the first CV onto the first one from the earlier curve. And to build it perpendicular towards us, I switch to the back view by clicking on F7. Zoom in here a little bit. And use the middle mouse button to place the next CV. This will ensure that it's perpendicular. If you try to eyeball this, it's not going to be perfect, as you can see. This is really important if you want to get symmetry, or rather if you're working with symmetry and you want to get a seamless transition. For the next two CVs, all I'm trying to do is place them somewhat evenly spaced, but it does not really matter exactly where they are or what form they describe. If you take a look at this now in perspective, I'm using Alt-L to quickly zoom into the scene. From the top view, this looks much like an L-shaped object, and this will become the first set of curves to use with the rail tool. The rail tool is located on the surfaces, swept surfaces, rail surface. In here, choose Generation Curves 1, also Rail Curves 1. The longer one that was sketched along the x-axis, that will be the rail surface curve. For this, switch the position to Implied Tangent. Implied Tangent is only for the center line if you're using symmetry. So the prompt line says select Generation Curve, click on this one. Then it says select Primary Rail Curve, that will be this one. Take a look at this now. It creates a very clean surface. Clean in two ways. Clean means that there's, in this case, no interior isoparms, so it's very low geometry. Clean also means that if you use diagnostic shading, you will hopefully get a very nice looking result. Now to test the tangency, or in this case it's called implied tangent, which again is only for the center line, start to bring out two new layers. The first layer I'm going to call curves, and I'm going to make this one actually invisible. This one allows me to quickly select the curves, assign them onto that layer so I can only evaluate the surface. Now I don't really usually like to put things on the default layer, so I'm going to create another one, call this one Surface, and assign the rail surface onto it. If you now on this one turn on Symmetry, you will get a visual representation of what the surface will look like once it's complete on both sides. Now for this, it looks fairly clean using just the single shaded diagnostic shading. There's two other methods. You can use the horizon vertical one. Look at this at an angle of about 45 degrees. In other words, if you look at it straight like this, you will not really see if it's seamless. It's always best to look at it at a steep angle. It looks very clean. But this also sometimes gets you somewhat dizzy. So what I like to do is use the single color diagnostic shading and use the small triangular pull down menu to choose reflections. These are not real reflections. These are just one that are generated by the software for you to evaluate the surface, but it's much nicer to see this clean transition between the two halves, like this. Okay, so now that you've created this, let's turn the symmetry off and also make the curves visible again. I'm going to select the surface and build a rail surface that uses two generation curves, meaning there's another one on this end. So go to Curves, New Curve by CVs, and I want to also snap the first CV onto the last one of this curve. Hold down Control and the left mouse button to place that first CV. Switch again to the back view and place the next CV using the middle mouse button. And then two more. In this case, I want to give this curve a distinct different characteristic, meaning it's going up versus the first one going down, so that you can see the resulting difference in rail surface. Go back to the rail surface tool, options. This time, select two generation curves. This could be the first, second, and then the center one is again the rail surface. And this surface, I want to assign onto my layer called surfaces and test the symmetry. So if you turn on the single color with reflection, you can see that the surface has a much more interesting flow to it, and it still maintains perfectly its transition across the top. In this particular case, we control 3 edges. However, there are cases where you may want to even change the 4th one. For that, you can use a rail surface that's using 2 generation curves. So for this, I'm going back to the curve tool, new curve by CVs. I want to snap my first CV, I'm holding down control, onto this curve. Switch to the side view. And again, I want to give this somewhat of a distinct different character. I'm using control to snap the last CV onto the last one of the previous generation curve. And use these 4 to create another rail surface. So go to surfaces, swept surface, rail surface. In the option, choose 2 generation curves and 2 rails. 1, 2 generation, rail 1, 2. And again, the result will be a very interesting and compound surface. However, even at this stage, there's still no control over the interior of this surface. For that, you can add additional generation curves in between. If you have a really complex shape, you could add multiple sections in here. However, for the sake of this demo, I'm just going to add 1 generation curve in between. Now, it's important that they touch the rail. So I'm using Alt-Control on the keyboard and then press to place the first CV. Switch to the back view, F7. Use the middle mouse button to place the next CV perpendicular. Place another one, and for the last one, I want to make sure that I'm back in perspective view, so I can place it right along here. Again, I held down Alt-Control to place that last CV so it touches. Finally, I want to make a little bit of an adjustment probably to this curve, and then you're ready to create a surface. Go back to the rail surface tool, choose 2+ generation curves. Again, you can use more than just 3. Click on the first, second, and notice you will start to get the go button. So again, you could click on more. Just going to choose the last one, use the space bar to confirm. First rail and then second rail. And this will create a rail surface. Now notice that for rail number 2 it says position failed. What this indicates typically is that the surface is making some sort of a sacrifice in order to create implied tangency over here and match the other curves. It had to fail the position. Now in a lot of cases it's barely visible. If I zoom in here, you might notice that there's a slight gap in between the surface and the curve. If you have to get something that is perfect all around, you might want to consider rebuilding some of the curves, or also changing the design to possibly get a better result. In this case, potentially I may actually want to intersect a section somewhere further on the rear part of this surface. Again, new curve by CVs, hold down Alt-Control, place the first CV onto the rail, switch to the back view with F7, place out 2 more CVs. Again, the second one was placed using the middle mouse button, and I like to use the perspective view to place the last CV onto the second rail. Again, back to the rail surface tool, options, 1, 2, 3 rails, spacebar to confirm, rail 1 and 2. Again, here you see that it gave a distinct different look to the whole thing, but also created somewhat of a small gap. This might have to be then fixed if necessary by the characteristic of this particular curve here that's forming the side. Again, this one was the one in the side view. However, in either case, if you take a look at the surface, turn on or assign it to the layer with symmetry, you will notice that it is seamless across, and it does have a very interesting and dynamic surface transition built in. This is a fantastic tool for almost all product and automotive surfaces that you may encounter. The tool rail also has a couple other features in it. I'm going to show you now. Next, I'm going to get rid of some of these things that I created, and I want to go back to making a simple rail surface. One generation, one rail. I'm going to turn off the implied tangency because I'm not going to use symmetry. I'm just going to make one generation, one rail. And with this, notice that in the rail control there's also something called scale. So you can also make a surface grow larger or smaller towards the end, even towards a point. Now, an important thing about this, making it come towards a point, this is scale 0, this is a good way of indicating a triangular surface. However, if you turn the CVs on, notice that the row of CVs, essentially in this location, are pinched together. Again, this is fine for visual representation, not for rapid prototyping. I'm going to show another trick with the rail surfacing tool. I'm going to switch to the side view and create a straight curve. Now there's different ways of creating a straight curve. One is to just use CVs, click the first CV and use the middle mouse button to place a couple more CVs. However, notice that the spacing is not very accurate. This is also very difficult if you're trying to create a curve that's straight but going at an angle. Almost inevitably, some of these CVs are going to be off. So for that, I like to use new curves by edit points. I can click once, use the middle mouse button, click twice. This will create a regular 4CV curve, except that the second and third CV are spaced evenly in between the left and right, and the edit points, which every curve has, are at the beginning and at the end. I'm going to repeat this process for the generation curve. Place the first CV onto that one by holding down Control, switch to the back view, and click once more with the middle mouse button to place out a straight curve. If you look at this in perspective window, it's just two straight curves. In the rail surface, I'm going to make sure that the scale is set back to 1. That's its default. Create one generation, one rail. Except this time, I'm going to add rotation to this whole thing. Notice that when you pull the slider, the rail surface starts to rotate around the rail. Now this stops naturally at 360. You could type in higher numbers such as 400 or even more, or you can click on the Alt button and with the middle mouse button click and drag over the number. Notice how this interactively lets you go beyond what the slider gave you in the first place. What you're looking at is a spiral surface. Now this surface on its own is not really useful because it's paper thin, meaning it doesn't really have any thickness to it. And there's few occasions where you may have to need a surface that looks like this. However, a lot of times, and you will see that later on this DVD, a lot of times you will use a surface such as this one as a temporary one to create a different one altogether, the end result. In this case, I use this a lot of times to, for example, I'm going to bring on a circle here, create a spring or bottle thread. This circle I'm going to scale to size 1. I'm just going to use the extrude tool, surfaces, swept surfaces, extrude. Again, notice that the curve turns white and it's asking me to activate it. Next, click on the edge to create a rail surface. Sorry, a extruded surface. I could also use the rail surface tool for this. This now, with this profile being circular, looks or starts to look like a spring. If the profile was more of a rectangular shape, then this could become, for example, a bottle thread or similar. Now this entire contraption I just created has construction history on it. In other words, if I change the size or scale of the circle, it will update the extruded shape. I can also select the rail surface, go back to the options of the rail surface tool, and in here I can also, for instance, change the amount of the rotation that I have. which will update everything. I could also, if I wanted to, change the scale, have this become slightly larger or slightly smaller, depending on what the effect is that you want. So this is actually a very useful tool once you do run into a particular situation where you need a temporary surface, such as this one, to create the right effect. Now there's a couple other things that I want to show while we're on the topic of these rail surfaces. The next one is how to extend a particular surface. Now if this was just straight, use the rail surface tool. I'm going to reset these, rotate to 0, scale to 1. I can easily extend this by building another surface here because it's straight in the side view. However, you will run into situations where you have a surface similar to this one that will need an additional patch at the end here. The tool that you want to use for this is called Extend. It's located under Object Edit, Extend, Options. In the options, the main thing to watch out for is Merge. With Merge unchecked, you click on the Go button. I can click on the edge and extend either towards the inside or outside of this surface. Again, just create a separate surface altogether like this. The nice thing about the Extend surface is if you turn on the shading, that it's seamless. And another option you have with the Extend tool is to not merge them. In other words, it will stretch that surface out but maintain its flow. Notice it gives you the question about deleting the construction history. Click yes. And this is the surface in its extended state. Now you can also detach a surface and a curve. Let me first show it on the surface. Under Object Edit, Attach, Detach, you will be able to click from either edge to a position where you want to detach it and split it into two. This works on both sides. I can come also from the opposite end. Once you click on Go, it will split it into two individual surfaces right at that location. This also works on curves. If you're in the side view and you want to detach this particular curve, go to Object Edit, Detach, click anywhere on the curve, and once you have the right location, click on the space bar to detach this curve into two. Just as you can detach, you can also attach these again. What I'm going to do is change a little bit the characteristic of this second curve, like this. And I'm going to attach these two to each other. If you go to Object Edit, Attach, Options, usually you will use the blend type, and I like to turn on Keep Originals. That way you can compare the two originals versus the new version. It says select object near attached location. That will be here and here. And notice that it creates a nice, clean and smooth curve, but it's fairly different from my two original ones. If you try the same thing with Insert Spans checked, you will notice that you get a much closer to what you had result. However, there is an inserted span right at that location, which you have to make sure that the continuity of that curve is actually correct. Finally, if you have a curve such as this one, and you don't want to use the Extend tool, but you want to just physically add some CVs to maybe change the design, you can always add points to a curve. Notice I selected the first CV here. If you go to Curve Edit, Modify, Add Points, notice how that end flipped over to the other side, meaning it reversed the direction of that curve. And now on this end, I can continue placing CVs to change the design that I have. Again, this also comes in very handy when working, especially with curves that you use for industrial design. In this next segment, I'm going to start using the flange tools to show you how to create part lines. The flange surfacing tools are located under rolled edge, fillet flange, tube flange, and tubular offset. Now, while these names are somewhat similar, maybe confusing, they have very useful, subtle differences in what they can do. For this particular demonstration, I'm going to switch to the top view. I want to create a rail surface similar to the one that I did earlier. Actually, I'm going to do this in the side view. Create a simple curve with CVs. Simple meaning not too much arch, just a little bit so you can see the full effect and power of that tool. Start a new CV onto the previous one and switch to the back view. And again, I'm going to place the next CV with the middle mouse button, go slightly down, place a fourth one, so it just creates a very subtle arch. If you take a look at this, once I rail this, surfaces, swept surfaces, rail surface, I'm going to use 1 and 1 for this. However, since I'm going to try out some of the tangency, I want to make sure that rail 1 is set to implied tangent. In this case, later on, if I decide to use symmetry on the surface tool, I will get the other side seamless. So now that there is a surface to play with, I want to create two different style curves on here and ultimately create curves on surface. So for this first one, I'm going to create a new curve. This is similar to how the tire rim was done. Create an open curve like this and use the object edit close function to close this up. Again, I could have also placed out a sphere, but just for the sake of the demonstration, I used the close tool. What I want to make sure is that I don't come to too sharp of a point. Otherwise, this next demonstration is not going to work. In other words, I don't want to create something like this. Definitely not something that overlaps like this. I want to keep this somewhat open, similar to this. I'm going to create another curve using CVs. Snap the first CV onto the grid, and then place the next one using the right mouse button, which constrains it vertically. And then place two more extending over the edge of the rail surface. Now for this, I'm going to project both of these curves onto the surface. Going to Surface Edit, Create Curves on Surface, Project. Click on both of them. And click on the Go button to confirm. If you switch to the perspective view now, notice you have two of the curves on surface here. These is what I will use to create part lines. Now, I'm going to take the surface and assign it to the surface layer. I'm not going to use symmetry just yet. I'm going to turn the curve's visibility off just so that I can keep this somewhat clean. I'm going to start with the closed curve on surface here. On this one, I will start to use the fillet flange tool to create two part lines, meaning one on each side of this curve on surface. Again, this is on a surfaces, rolled edge, fillet flange, options. Now there's a lot of options in here to choose from. Let's see what some of these do. It's asking in the prompt line to pick input surface curves. So I'm going to start and just click on this curve on surface, and notice that I get a locator that shows me a radius or fillet and a gray line down here that is the flange. So in this particular example, I'm going to choose not to have a flange down there. So I'm going to turn the Create Flange option off. Also, for the fillet, I want a radius that is closer to a real part line. So 1 is too large. I'm going to try 0.1 and zoom in to kind of get an idea of what the size of this fillet might be. Notice again that in this case it builds it away from the curve on surface that we had. Once you're satisfied with what could be the result, on the bottom, click on the Recalc button or use the space bar. And this should create the first side of the fillet. If this is the result that you want, you may want to check it also in the other corners, make sure everything's fine. Then click on Next click on the curve on surface again, and now you want to flip the direction of this radius. If you go over here to the options in fillet, there's a flip option which just puts it over to the other side, and you can again click on recalc, and this should create a second set that's going along the other side. Now the nice thing about this technique is that this automatically creates curves on surface. In other words, if you go to pick COS, curves on surface, there should be one on this edge, and the original one that I created in the middle by projecting from above. So I'm going to start to delete the temporary ones that I used. So all that you're left with is, if you pick curves on surface, 2 here. This will allow you now to, for example, trim divide these 2 areas and thus create a nice part line. Let's try this out. Let's go to surface edit, trim surface, click on the surface. I'm going to click both inside, outside, and in the middle and use divide. And now I should be able to choose the rail surface. There's just a thin strip in between, and delete it. Now the reason why I didn't choose to just discard the middle, but I actually divide it, is so that I can start to select these 2 objects as separate geometry and possibly assign different shaders to it. However, just for evaluating the surface, if you take a look at this, you can start to see exactly what this part line is. Now keep in mind that this is not a true part line because it actually comes to a point. Most often a part line would actually have a small gap in between these 2 fillets, and that's what I'm going to try and create over on this side with the tubular flange tool. So while the first one here, the fillet flange, was building the flange away from the curve on surface, the other tool located here, tube flange, will build it on the curve on surface. So what I need actually here is to create an offset first. That's done with tubular offset. So go to surfaces, rolled edge, tubular offset, options. In here, let's just start to see what this does. Click on the curve on surface. Here's the trimmed edge. And notice that it creates a very, very large radius for this. Another thing that has happened, because I've trim divided this earlier, it also divided this segment away here at the end. For this particular tool to work fine, right now I could use the same one here, but I actually want to have one continuous surface. So a lot of times what I'll do is I'll just delete the segment that got trim divided, take the original one and untrim it. Now this will also untrim the area back here, but I'm not too concerned about that yet. I'm just going to leave this untouched. Rather, I'm going to go deal with this curve on surface, go back to the tubular offset, because I want to create 2 curves on surface off from this. This, again, radius is way too large. Let's choose one that is, say, 0.2. And this will create a surface plus curves on surfaces. So I'm going to show you what that looks like real quick. This is, again, just a tube that resides on the surface. You can also choose not to have a tube at all, or you can also choose to create something like a groove, for example. That also works. Right now there's a groove that's just on the top portion. Again, you would have the option to flip it, for example, below. However, for this particular example, I'm going to choose no surface, so it will just do the curves on surface. If you click on the recalc button, that is exactly what it created. Notice that there's no surface here, just 2 additional curves on surface left and right of it. So these 2 now will be the guide to use the tube flange tool. I'm going to get rid of the curve on surface here in the middle. Go to rolled edge, go to tube flange, and again, without changing anything, let's just take a look at what this does. If I click on this edge, again, notice that this particular tool builds on the curve on surface directly. So there's a couple things that we need to change. First of all, like I said, for this example we will use a little bit of a flange. However, I want a much smaller radius. I'm going to start with 0.1 and I'm going to flip this over the flange over to the other side like this. And I want to create eventually somewhat of a gap here. For this radius I want to increase this a little, let's use maybe 0.15 like this. And then the length of the flange, I want to decrease this quite a bit, maybe 0.1, so that this will get a nice little channel when it's done. So with this one here, I'm pretty happy. Click on Recalc. And again, it creates a flange surface including the fillet. Next, click on the other side. Navigate to the locator and notice that it automatically recognizes that it needs to be the opposite of the first one. In other words, there's no need for me to change anything in the controls. It automatically placed it correctly like this. Click on Recalc. Now if you take a look at this, notice again that there's somewhat of a gap in between these two. That was done on purpose. For this to get closed, one fast tool always is the skin tool. Theoretically, there's also different ways of doing this, such as using the rail surface tool or other ones. But for this is good enough. Again, I'm going back to taking my surface, and in this case, I'm actually going to just trim the surface, use the keep function, and keep both sides in between the part line. This is also going to, again, trim away what was earlier left over on the left-hand side there. And again, if you look at this in close-up view would create a very nice part line with a groove in between. And that is two different techniques of very accurately and quickly indicating part lines. Now notice that when I turn the model off, there's a lot of white dots and some irregularities. This depends greatly on how you use diagnostic shading. A lot of times, depending also on what size you're working on. I'm working in centimeters with a grid spacing of 1, and the tessellator is a part that controls the size and or the accuracy of some of these details. Accurate might give a little bit of better result. If you lower the tolerance, you might get even better results. However, at a certain point, you will notice that it takes a long time for the software to calculate the surface, and would also slow down the way you view this in a shaded mode. So a lot of times I'm not too concerned about whether this is displayed accurately in diagnostic shading. I like to keep it rather on fast with a slightly higher tolerance because it displays much faster, and I would create a rendering with a higher resolution to check if the results are really exactly what I want. Now that we've covered a whole bunch of these new surfacing tools, such as the rail tool, and seeing some of the different options you can do with this, you also got introduced to the first idea of temporary surfaces. In addition to that, see how you can do some quick indication of part lines and other details. I'm going to start to use all these to create a simple demonstration on how to create a mobile phone.